Assalamualaikum warahmatullahi wabarakatuh and a very good day to all of you. So this video is the extension of the mesh analysis where for these examples, we have two examples. All the circuits have their current source shared by two mesh current loops. So what to do, okay, when you have this kind of circuits? So we have first examples. The question is find Vx, which is the voltage across the current source. And the example 2 is much more complicated, which is find Ix and Iy. Okay, let's start with example number 1. So first of all, what you need to do is to define your mesh current and the direction of your mesh current. So we have two loops here, I1 and I2, and both are defined as a clockwise direction. Okay, and as you can see there, we have 6 amperes as a current source that shared with two mesh current. So how to do and how to solve this circuit? Okay, to solve this circuit, we need to use an approach what we call super mesh. So super mesh is actually a mesh current that consists two loops. So this is what we call mesh current, because we cannot actually solve this branch current here. Okay, so any elements that are connected in series with a current source and shared with two mesh current, we can actually ignore in our step of analysis. So we concentrate on the super mesh. Okay, so KVL for super mesh. Okay, so based on that, we have negative 20 plus 6I1, and then next is 10 I2 plus 4 I2, and this is equal to 0. And then we rearrange this one, we obtain 6I1 plus 14I2 is equal to 20 volt. Okay, so this is the first equation that we obtain. Okay, so we have two variables but one equation, so meaning that we need another equation to solve this. Okay, so the second equations come from this branch. Okay, so we know that the current direction of the current source 6 amperes is actually in the same direction with the mesh current I1. So we assume that we can obtain I1 minus I2 is equal to 6 amperes. Okay, so right now, as you can see, we have two variables and two equations. So by using calculator, so this one just mode 1, mode equations, and then we have two unknowns only. So 1, and then this one is negative 1. Oh, sorry. Okay, it's okay. So sorry, this one is 6 actually, and I2 is 14, and this one is 20. And the second equation is 1 and negative 1 and is equal to 6. So my answer is I1 is 5.2 and my I2 is negative 0.8. And the question is find Vx. Okay, so to find Vx, what you need to do is to obtain the voltage from this point to this point, which is, I think we define as a B. Okay, so what is your VAB here? is actually equals to okay, so I redraw the circuit to let you know what is a VAB. So this is the polarity of VAB. So and then we use the KVL. So we will obtain this one is negative 20 plus 6I1 plus VAB equal to 0. And my VAB is equal to 20 minus 6I1, where your I1 is actually from the mesh current analysis 5.2. So from that, you will obtain that this one 6 multiplied with 5.2 is 331.2. Okay, 31.2. So 20 minus 31.2. So this one will become negative 11.2 volt. Okay, so that is your VAB. So my VAB is negative 11.2 volts, where we know that VAB here is actually okay, 2 ohms. This is A, B, and then this is 2 ohms, and we have a current source that's 6 amperes. Okay. And so this is VAB. If I draw a equivalent circuit, it's actually like this. VAB with a magnitude of negative 11.2 volts. Okay, and then this is your Vx. Okay, so from here you can get your voltage drop across 2 ohms. Okay, so V2 ohms is actually 6 amperes. So 6 multiplied with 2 ohms, we have 12 volts. Okay, so polarity is like this because the current is flowing from positive to negative. So by using KVL, okay, so assuming the direction like this, so I will obtain 12 volt first, and then plus Vx, and then negative VAB. So it's equal to 0. So my Vx is actually VAB minus 12, which is my VAB is actually negative 11.2 minus 12. So this one will become 23.2 volts. Okay, so the voltage across the current source is negative 23.2 volt. Oh, sorry. The polarity of Vx is actually reverse. So just this one. Okay, so I need to redo again. So this one will become negative, this one positive, right? So, but still, I assume that the current is flowing counterclockwise. Okay, so I will I counter first the 2 ohms, so which is this one will become 12 volts. Okay, minus Vx minus VAB equal to 0. Okay, so my Vx will be 12 minus VAB, 12 minus 11.2. So this one will become 23.2 volt. Okay, so that is my Vx. So we continue with example 2. So find Ix and Iy. So same with example 1, we have a current source that are shared with another mesh current. So the first step is actually you need to define your mesh current, which is I1. This one is my I2, and this one is my I3. Okay. So right now, as you can see, we have I1 and I3 shared the current source. So meaning that for this one, we need to use a super mesh for this loop. Okay. So for this one, for the super mesh, so we start with 4K. So as you can see, we have two currents, 4K I1 minus I2 plus 2K I2 minus 4 plus 4K I1. Okay, 4K I1 plus 2K I3 plus another 2K I3. Okay, plus 10 volts. So this is your super mesh equation. So just check again. So 4K I1 minus I2, and then 2K this one 2K I1 should be 2K I1. Okay. And then 4K I1, 2K I3 plus 2K I3 equal to 0. So I think this one, if you simplify, you will obtain these equations. Okay, so you simplify, you will obtain this equation, and then this equation is your first equations. And then the second equations come from the I2, mesh current I2. So the mesh current I2, as you can see, is actually equals to 4 milliamperes. So I think you can substitute I2 in equation number 1. So it will be 10K I1 plus 4K I3. This one is negative 6. Okay, so this one negative 4 multiplied with 4 is actually negative 16. So and then move towards this. So this one become positive 16. So meaning that this one is positive 10. Okay. Next is actually come from, so right now you have two variables. So another variables equations come from the this branch current. Okay, so right now, as you can see, the current source direction is similar to I1. So you need to write down equals to I1 minus I3 is equal to 4 milliampere. Okay, so right now, as you can see, we have two equations, which is this one comes your second equation. This one is your third equation. So solve equation number 1 and also number 2. Sorry, no, equation number 2 and also equation number 3. You will obtain, so this one is 10K. This one is 4K is equals to 10. Your A2 is 1, negative 1, and this one 4, negative 3. So it will give you the values. I1 is 1.86 milliampere, and your I3 is a negative 2.14 milliampere. Okay, so right now the question is Ix and Iy. So from here we can obtain Ix is actually similar to I2, which is 4 milliamperes, while Iy, as you can see, is actually a combination of I1 and I2. But right now, the Iy is actually the same direction with I1, so we assume that The equation is I1 minus I2. So your I1 is 1.86 milliampere minus minus, which is plus 2.14 milli. So you should get around this one mode to be mode 1.86 plus 2.14. So it will become 4 milliampere. Okay. Is it correct? So you need to double check. You can check it by maybe by using simulation, which is LT Spice, to obtain is it to double check, okay, whether your answer is correct or not.